Hello, I'm Pier Francesco Valerio, Structures Manager in Highways England, and today we're going to speak about changes to the DMRB document on the assessment of concrete highway structures and bridges. So the background to the new DMRB document CS 455. The DMRB, the Design Manual for Roads and Bridges, has been updated as it contained aging documents of varying quality that do not reflect the needs of the users. The updated DMRB will be consistent in style and format and is intuitive to use, with clearly defined requirements in a reduced number of documents, and advice which is much more concise and directly linked to requirements. It reflects industry best practice and encourages innovation and complying with relevant EU and UK legislation. The documents are aligned with our asset management policy and strategy. Highways England has recently developed and adopted an asset management policy and strategy. This includes all the work that is undertaken to support the business through concept, design, construction, maintenance, and end of life for all of our assets, including structures. Associated with the strategy is a plan to transform and continuously improve. It will support better planning and secure longer-term investment in our aging assets. Key themes in the strategy are customer service, supporting users of our network, strategic planning and service delivery, ensuring optimal intervention such as maintaining safety and fitness for service, better use of asset knowledge to understand risks and support planning, adopting a whole life approach, support for people with tools and training. Having a robust and consistent standards and providing guidance is a key component of the asset management approach and underpin the need for the complete review of the DMRB. The new DMRB has now been published and is easier to read and understand. Our new documents clearly state requirements using shall or must. The new clause numbering is based around the requirements, with the top level being the requirement and the second level being advice. Supporting advice uses should or may verb forms, and notes use can. The document we are speaking of today, it's the assessment of concrete highway structures. The UK motorways and trunk road network contains in excess of 10,000 concrete bridge structures, and their safety is assessed through the DMRB document CS 455. The load carrying capacity of highway structure is assessed numerically every time this is required, for example, due to the change in loading or condition of the structure. This webinar is concerned with the updates to the document used to assess this structural capacity, and the CS 455 applies to all highway structures made of concrete, including bridges, retaining wall, culverts, foundations, buried structures, masts, tunnels, and some gantries. The document incorporates provisions that were previously contained in satellite standards dealing with the assessment of deteriorated concrete structures or with steel corrosion, such as the old BA51 and BA38 and BA52. The predecessor of the CS 455 was the BD44. The new standard structure and BD44 15. That document amended the British Standard 5400 Part 4 and is now fully consistent with the overarching DMRB document CS 454 for the assessment of structures, the latter containing the basis of assessment and loading. In CS 455, all the material properties and resistance checks are contained in a similar fashion to the Eurocode's structure. The slide shows how the old layout of the BD44 has been reflected into the new layout of CS 455. there is now no need to use the confusing structure and appendix that amended BS 5404 anymore, and the whole section 5 that was huge about assessment for reinforced concrete is now split into 4 sections in a more consistent way. In terms of the main changes to the document, in addition to the editorial changes to be aligned with the new manual of development for documents, the restructuring previously described and a number of minor changes, some more substantial changes have been made actually. The first is about the worst credible strength. The guidance for evaluating worst credible strength has been expanded to be consistent with currently published EU standard and the Eurocodes. In CS 455, material strengths are either taken as the characteristic value specified in the original design or a worst credible strength, which is defined as the worst value of that strength which the assessor realistically considered that could be obtained in the structural element under consideration. BD 4415 content needed to be updated because he only gave an estimate of the mean instead of the 5% quantile, which in some situations is more appropriate, and it was inconsistent with other current documents like the Eurocode BSCN 1990 Annex D and the BSCN 13791 for the assessment of in situ strength of structures. CS 455 has now some new options for calculating the worst credible strength. The document gives now the flexibility to use a different approach in different situations, with its conservativeness related to when a smaller or larger number of cores are available, and also in relation to the criticality and expected mode of failure of the location in object. So option 1 would be calculating an estimate of the 5% quantile of the in situ strength based on a known coefficient of variation for the location being assessed. That would be the default option, but other options are permitted, like option 2, which is calculating an estimate of the 5% quantile of the in situ strength, but based on the sample core test data, which is the approach in BSCN 13791. Which is good for a large sample size. Option 3 is an option about calculating representative strength parameters using Bayesian analysis with a prior distribution based on strength parameters assumed in the original design. This is a statistical probabilistic approach that requires specialist input, but it could be of value in some cases. And the fourth option is what was the standard approach in the BD 44, which is now clarified that is applicable when the mean strength is justifiable in terms of worst credible strength. For example, for specific verification, when there is a global or ductile failure mechanism where an estimate of the mean strength is justified, that will give values which are still on the conservative side. In cases where there is a very small number of cores and the 5% quantile is needed, option 1 is the default option. Another change which has been important has been to the section on the shear resistance, with Stratton time modeling guidance now explicitly added. The approach to calculate the shear resistance of reinforced concrete element has been simplified, rationalizing the approach that was present in BD 4415, so that there is now a single formula that also caters for cases where there is a short anchorage beyond the support through the anchorage parameter gamma. This is not a change. This will not change in the results compared to BD 4415 in practice, but the formula is now written in a way that is more consistent with what is the capacity further away from the support and the one within 3 times D from the support, which is the area where research show that there is an increase in capacity in shear due to the arching effect of being close to the support, but there's also a potential reduction on shear if the anchorage is not adequate, and this is reflected by the parameter gamma. For members with shear reinforcement, in addition to the additive approach and the variable angle shear thrust approach to Eurocodes already covered in BD 5415, which are presented here in the top of the slide and in the middle, extensive guidance has been added on shear assessment using strut and tie approaches that can be of value in a number of situations where the application of classic approaches is not fully justified or results in excessively conservative outcomes. Another change has been providing some clarification for the requirements and advice on serviceability limit states assessment for pre-stress structures. SLS assessment for pre-stress structure is important for two reasons. The requirement for that was first introduced in BD 4415. The two reasons are, firstly, because pre-stress bridge, particularly where post-tensioned, are often more vulnerable to the effects of corrosion on their tendons, so limiting the stresses to below those leading to excessive cracking is of value in preventing water ingress. Secondly, because, or at least preventing, in terms of understanding whether the structure is at potentially a level where there is some cracking that may have triggered water ingress. The second reason is because many pre-stress structures would have been designed to BS 5400 principle as being class 1 or class 2, and assessing them to those classes rather than solely at ULS gives a better idea of their performance in service and the likelihood of being in need of more attention or otherwise. CS 455 introduced a clearer process and defined an SLS class to be reported without needing to resort to the 5400 part 4 routinely, and in most cases simple stress checks are sufficient. This slide summarizes the procedure for checking SLS for pre-stress structures with the four SLS classes related to the tensile stress limit, compressive stress limit, and the consequence of each of the class. So the procedure for evaluating, assessing SLS class and the action potentially to be taken where cracking at SLS is expected is spelled out better in the document. Another change has been made, actually a number of changes and improvements based on research and departure from standards approved in recent years to the provisions for bond, anchorage and bearing as supports for the reinforcing and pre-stressing steel in concrete. In particular, the most significant change in the new section on bond, anchorage and bearing is the introduction of a new approach, also based on recent research instigated by IWS England, that permits to evaluate the bond capacity of reinforcing and pre-stressing bars when there is reduced concrete cover, typically due to spalling and delamination as supports due to corrosion. This will lead to more realistic bond capacities than what would have been assessed through BD 4415. There's a new section bringing together bond, anchorage and bearing in the document, presented as an anchorage resistance, which ties in with also the gamma factor for the reduction of capacity in shear, and there is a new K-COV factor for accounting to account for low cover and confining effect of links. This is there is also a simpler and more consistent rule for the 50% enhancement of bond over the bearing area. These clarification and changes are expected to bring some advantages in more realistic assessment of situation when there is a theoretical failure in bond that would have been to the previous standard, that with this document this may be mitigated. To summarize, then the major impact and benefits of the update of the BD44 to the CS455 is a more logical document structure, which is consistent with Eurocode's format and leading to ease of use, and also a better integration with forthcoming assessment Eurocodes in due course. Changes and guidance on word credible strength, shear, strut and tie, and SLS for pre-stressing and bond anchorage can lead to more accurate assessments. Cost savings are expected to arise for those more accurate assessments, potentially leading to less unnecessary interventions. And then this reduction of interventions could potentially also lead to reduced network disruption and less safety risk to the workforce and public overall. Some acknowledgement. This webinar was prepared with the assistance of Dr. John Shave and Dr. John Bennett of WSP, who have been the co-authors in the drafting of the new CS455, and whose contribution is gratefully acknowledged. In terms of communicating the changes, we are communicating the key changes with DMRB. Bulletins are available to view on the Innovation Hub website, which is linked here in the slide. We have prepared several webinar tutorials such as this one to explain key changes to individual documents. We've made the presentation to external organization to explain the update to DMRB, and the items related to DMRB are often in technical publication. A new DMRB document can be found in the Standards for Highways website. Withdrawn or superseded documents from 2001 can be found in the archive section of the website. For older documents, please email our standard inquire address. New documents are to be implemented as soon as they are published, as set out in GG 101, but exception can be proposed should implementation result in significant time or cost. We welcome feedback and questions, and this can be posted using the email address shown. Thank you for your attention.